Okay, so we're gonna start. I can't see anything that's happening on the Zoom. So if there's any people should be able to join without being allowed to join the meeting. So I'm not going to introduce myself because everybody seems know me here. This is a PowerPoint presentation that I long-term for the Global Leopard Conference in March, and that is presenting the results of a long-term, 3 years, study that was conducted on Ongava based on data from camera traps and GPS collars data collected by Ken and the ORC at the time. And it's basically looking at the population size, population composition and size of leopard on Ongava. There we go. So obviously for everybody else at the conference, I needed to give a bit of intro of Ongava, and I skipped all the importance of apex predator and leopard and everything. So now I need to do the opposite here, because you all know where Ongava is. But I just want to stress the importance of studying and better understanding large carnivores, because being at the top of the food chain, they have the potential to impact the whole ecosystem and the trophic level below them. Some significant work has been conducted with wolf in North America. In Southern Africa, there's still a lot of things that we don't understand. So focusing on large carnivore is a good way to start understanding how an ecosystem works and can be impacted by high trophic level. Importance of leopards. Well, paradoxically, leopard is one of the cats that is most widely spread across the world, because it not only occurs in Africa, but also in India. In Asia, sorry. And even though that's a species that we can easily, quotation mark, count because we can identify individuals, that we actually have no clue or no reliable estimate of their population size globally. So we know they are decreasing, but compared to, for instance, spotted hyenas or lions or cheetahs, we have a far less good idea of how many leopards are left in the world. So that's important to try to gather as much information as we can on the ground. So Ongava, I'm gonna skip that. At the time of the study, the northern fence was Etosha, was not electrified, if I'm correct. And that's basically characteristic on Ongava compared to Etosha, and the surrounding land is the ridge and hills, a lot of relief on Ongava, which basically make it a great location, a great area for leopards, compared to the flat neighboring Etosha and the farmland around. Even though some of them have very good habitat for leopards, they might not be so leopard friendly in terms of human-leopard interaction. Ongava, I'm not teaching you anything here, luxury tourism reserve. So there is a lot of traffic, game drive and safari vehicle crisscrossing the reserve almost on a daily basis, with high and low through the year, with a high tourism season and a low tourism season. But even though there's a lot of traffic, leopards are actually very rarely seen by the guest. We see them once in a while at the waterhole on the cameras, or like when guests are having dinner or staying up late, but it's really not something that we see regularly. However, we have long-term records of them seen at the waterhole by the camera traps, at least since 2009. So the question that raises is really how many leopards live on Ongava? Do we see every time the same individual with the camera traps at the waterhole? And so maybe there's like 5 or 10. And then we don't see them on game drive, or are they more than those few that we see at the waterhole? So we used 2 methods to answer those questions. The first one was with GPS collars that were deployed in 2013. One on a female that was taking a GPS location every 6 hours, and one on a male that was taking a location every 3 hours. Why the discrepancies? Not that females are less important than male, on the contrary, especially when we look at population dynamics, but because the female leopards are smaller in weight and body mass, then they cannot carry as big of a collar. And so in order to try to, so they have a smaller battery, and in order to try to have a full year of monitoring, it was necessary to reduce the number of points that collar was taking. This is why it's not the same schedule on a fixed frequency. And then we use camera trapping at 12 waterholes over 3 years, so 2012 to 2014. You'll notice that that overlaps the GPS collar period. And this is a map of where the camera trap were located. And in black, you have the waterholes that were intensively monitored. So there was long-term monitoring. The camera traps were active during most of those 3 years. And in contrast, the light gray one were mainly monitored only during the dry season for a shorter period of time. And the numbers indicate the number of independent observation of leopard. Now that's a key concept, the independence between observation. Basically, we don't count the number of pictures because the number of pictures can just be taken from the same observation, the same individual, just spending quite a long time at the waterhole. So we define independent event as the event separated, the images separated by at least 30 minutes. So if there is a leopard seen at the last time at 10:30 in the evening, and then the next image is 10:35, that is the same event. However, if the next image is at midnight, then that is a different event. All right, so what did we find? From the GPS collars for which the data was collected for a full year, we derived orange. And this is what you see here. So the colors reflect the utility distribution. The darker, redder it is, the more intensively that area is used. That's for the male and the female. And then what we see is that in terms of 95% kernel, so those are kernel oranges, we've got a male about 193 square kilometers and a female at 122 kilometers. Hi, Stu. Square kilometers for the orange size. They overlap about 64% for the female. So 64% of the female's orange overlap with the male and 40% of the male orange overlap with the female orange. We can see that these individuals are not restricted by the fence. We know, for instance, that the female definitely crossed the 2-meter high fence that is electrified. The male, there's no really clear indication that it went out. The orange that spills here is basically overspilling from the kernel, so that's not really accurate. But here, definitely, the female moved out of the reserve. There is intensive use of the central ridge for the female. Where's my thing? The central ridge for the female and the central hills for the males as well. And so, based on that, what we're trying to look at is, okay, how many oranges of males and female could we possibly fit on Ongava? So we looked at the within sex overlap between leopard territory taken from the literature. There's basically nothing really known about leopards in this area. But what we found is that basically there's between 20 to 60% of overlap between the 95% kernel, so that's the one that are shown here, and 0% for the core. The core is basically the 50%, so that's that core area. So what we say is, okay, how many core can we fit that don't overlap? And then the overlap between the outside of the core, the periphery of the orange, can be between 20 and 60%. So that's basically what it does if we just try to plot some of them. And then we would fit for females between 3 to 6 and for males 2 to 4. So try to remember those numbers. I will show them again a bit later. So that's from the GPS collars. We predicted that we should have maximum 6 female, maximum 4 males on Ongava. So not that many. That could explain why we don't see, or guests don't see leopards that often on the reserve. What about the camera trapping data? We had 407 independent observation of leopards at 10 of the 12 waterholes that were monitored. So for some waterhole, we never see leopards. And here what you see is that the total number of animal identified, so that's based on the rosette patterns on those animals. Wet season, usually you see that during the wet season, we actually don't identify new individuals. We actually rarely saw leopards at the waterhole during the wet season. That's not really a surprise. And then during the dry season, this is where we identify most of the individuals. In terms of numbers, well, we identified 29 individuals, 12 females, 15 males, and 2 juveniles of unknown sex. So that is much higher than the 10 that we predicted by the GPS data. So what is going on here? We looked at the capture histories in much more detail. So the capture history is when and where each individual was seen. And this is how it looks. That is the first year, that is 2012, was the wet season and the dry season. Each line is an individual, and then you can see when a point or a triangle indicates when it was seen. First season, second season, third season, or third year, sorry, first year, second year, fourth year. You see again that during the wet season, there's very few observations. From this, so we saw the collared female and the collared male, which is a good thing. From this, we can identify two types of individual. The first one is individuals that are seen quite often, so regularly, and then across years. So during the 2013 dry season, that individual was seen, and also during the dry season in 2014. This individual here was seen during the 3 years, okay? There's another type of individual like these two, just seen just a couple of times and then never seen afterwards or before. And same here, that individual was definitely present on the reserve here, seen quite often, but after that, never seen again. So from those two types of capture history, we identified or defined resident individual and transients. And this is a very important concept because usually when we measure or we compute population density or population size, the transients are not really taken into account because what we're interested in is the number of residents, the number of animals that will establish a home range in that area and that will reproduce as well in that area. So if we look at the resident population, we have 6 females and 4 males. Do you remember the number from the GPS data? So basically we are saying the same thing. So even though we have a very high number of identified individuals, only a small portion of the population is resident, basically a third almost. The rest, well, it's up to everyone's guess to know what's going on there. So the two methods are in very good agreement, about 10 resident leopards. In terms of densities on Ongava, that place us well within the range of Africa. What you see here, Namibia as a whole has actually a lower population density. Not surprising because there's a lot of areas that are drier and less profitable for leopards than here. So that's kind of drive the density lower. And then the top higher density ever recorded, at least in Namibia, I'm sure that there's other areas that is very high, but it's in Okonjima. This is very interesting because we are now starting to work with Okonjima, trying to understand what's happening there. They have extremely high density of leopards. And their leopards don't seem very willing to cross their borders, their fences. So they do, but it's not like they really have a spillover. They can see the same leopard for years and years and years, and all of those leopards, they see them regularly. So we're not too sure what's going on there. They also have a very high population of brown hyenas. What they don't have compared to us, though, is lions and spotted hyenas. So that's a different ecosystem. That's also wetter than here, more profitable than here. From our data, when we look at when each individual was seen, so we looked at the time difference between the sighting of different individuals at the same waterhole, we could find no evidence of spatial partitioning in the waterhole usage. So each waterhole could actually was used by several individuals, sometimes within a matter of minutes, very often matters of hours, but sometimes matters of minutes. So there doesn't seem to be a lot of competition, at least for waterhole access, which is not necessarily surprising in an environment like ours. Some limitation though. Obviously, we had only 2 colors. So the home range of those 2 individuals, well, there's 1 male and 1 female. That's what it is, but we can't really draw any general conclusion on the home range size of leopards in the areas. The camera traps were not deployed specifically for leopards. They were deployed at waterhole for more general survey. And we know that if you really want to count leopards, then you need baited station. Best idea is also to have paired cameras, so then you have both sides at the same time. And waterhole are not necessarily a good location to trap leopards, camera trap leopards. Another reason is because we know that they make use to just small puddles or a bowl out of the kitchen that is left or a leak under a tank. We know that those individual leopards have no problem coming to drink in very close proximity to human habitation. So those leopards, if they don't need to go to the waterhole where there might be light or there might be elephants, so it's easier for them to just go under the tank and drink from a puddle in the sand or in the rock. Something that I really want to draw attention to for people who will be working with camera traps is that the capture history can be extremely misleading. So if we have been using only the camera traps, look at the color female. She was seen like 5 times. That's an individual that could have been easily appeared as a transient from the history, the camera trap history. But we know for a fact that she was resident on Ongava for that whole year. Remember the colors, that's when the color were deployed for. Between this, she was there. She was on that hill. She was coming to OGL to drink from the leak, from the tank, most probably. So it shows that using waterhole camera traps for leopards can be extremely misleading. So the combination of the two methods actually just provide us with a much more clear and reliable conclusion. The funny thing is like a lot of topics, or like a lot of things in science, is like now that we answered our question, which is how many leopards are on Ongava, we have many more questions. The first is obviously, who are the transients? Are they all subadults that are looking for territories and then emigrate? So they're all born here, but then they immigrate because there's no more room for them to establish territory here. Are they coming from Etosha? Because here we're attractive because of the environment. Are they coming from the farm? Because we're also attractive because we don't shoot them or trap them. And then if they are initially born here, where do they go? Where do they go after here? What happens to them? That is something that can only be answered if we manage to catch them and put some GPS trackers on them so we can see at least where they go after we catch them. Before, where do they come from? That's going to be camera trapping or report from pictures. How long do the residents hold a territory? If there's only 10 residents and there's about 30 individuals, not at the same time, obviously, but we can most probably estimate that there's about another 10 individuals that are passing by at any moment, must mean that there is some clash over territories, some competition. So how long do the residents hold the territory? One thing that we know is the collared male, remember, was collared in 2013, was still resident in 2019. Seen at Sidocrace, pictures from, I think it was Kone, it was looking in a very good condition, so most probably has not been pushed away from his territory. So it's quite a long time. That is something that we are going to answer very soon, because basically we're going to process all our leopard cameras, trap data since 2009 to up to now, to individual ID. So we're going to see how long we see those individuals. What's going to be interesting is most probably we're also going to be able to answer about the transient, because then maybe an individual that we saw in 2009, 2010, we don't see it for 4 years, and then 4 years, 5 years later, it just comes back here. So we're going to also have a clearer picture on those transient resident population. And obviously now more in terms of the hospitality questions, like why don't we see leopards on Ongava? Why do the guests don't see leopards? Is that because they are very shy? From the few observations that I have, it doesn't seem the case. Like when they're at waterhole, leopards are very chill. They're just like, they come, no matter the noise and the lights, they come, they drink, they do their business and they go. On game drives, I don't know, I've never seen them. But also the fact that we do only game drive during the day probably reduce the probability of seeing them. But also, even if we were driving at night, the vegetation is very dense, so it doesn't lend itself to good observation of leopards, who are in any case quite secretive species. Rugged terrain, why would a leopard go in the plains when he can stay on top of the hill? He has rocks to crawl under, he's got dassies, he's got safety. So most probably those leopards made so much intense use of the hills that we can't even go there, because walking in there, the probability of seeing a leopard is going to be very low. Is that because we've got too many lions? So I give lions here, but obviously hyenas, that the competition down in the plain is just in any case so high that they really try to avoid those areas and only come there at night, or in time where lions and hyenas are not there, and that doesn't necessarily correspond to the time where there is a game drive there. All those questions we really don't know what's going on there. But the fact that the guests don't see leopards don't mean that they're not here. So I know it's frustrating, but that's basically that question is still not answered. But yeah, I think that's it for that short-ish presentation about our leopard data on Ongava. That's not Ongava. That's the Goas female in Etosha.
Thank you.